Water, the signature of planet Earth, essential for all life. Indifferent to our daily lives and commitments, with its many forms and ever-changing intensity, water can abruptly alter the way we live. We need water to survive, but we also need to be respectful of its power. Just as water gives life, it can take it away. For example, when there's too much, or when there's not enough. We need to understand how water works and how it will affect us. This kind of work has a name, hydrology. It means the study of water as it moves through the environment. The scientists who do this are called hydrologists. We're going to show you the different ways hydrologists study the water cycle and how important this work is to each of us. Rivers of all shapes and sizes divide our nation's landscape. Rivers are utilized for everything from drinking water to transportation to recreation. So it's important for hydrologists to be able to determine how rivers will react to different conditions. Hydrologists can predict a few hours or days into the future the changing river levels, the speed at which the water moves, and whether an area will be threatened by flooding. Hydrologists make river level forecasts, which are very important for emergency managers, engineers, and others who have the responsibility to protect citizens from the effects of floods. River predictions also help reservoir managers determine how much water to keep or release for such uses as hydroelectric power generation, irrigation, recreation, and flood control. Rivers include a main channel, where the water normally flows, and floodplains, the low-lying area that can get flooded, along either or both sides of the main channel. The boundaries between the main channel and the floodplain are called riverbanks. Floodplains are sometimes used for farming and industry, or for parks and playgrounds. People even live on floodplains.
The height of the water in a river or its level depends on the shape and slope of the river channel and on how fast the water is flowing. Rain and melted snow drain into small streams which make their way to the river, increasing its level. When too much rain or snow melt reaches the river, water can spill over the riverbanks, causing a flood.
The key elements in predicting floods are knowledge of how much water is in a river, how much more water to expect from rainfall and snowmelt, and the ability to track the water as it moves downstream.
In the United States, measurements are taken at over 7,000 river locations. In the National Weather Service, hydrologists at river forecast centers use sophisticated computer technology to combine these measurements of rainfall, snow, and river level. This helps them predict future river levels and provides the basis for issuing river flood warnings.
Flash flood warning for eastern Clark County until 11.
In order for hydrologists to predict river levels, they need to know where, when, and how much rain falls. Too much will cause floods. Rainfall occurs when tiny water particles in clouds grow into large drops, too heavy to be suspended by rising air currents. Rain can fall in small areas of less than a mile, or broad areas many hundreds of miles across.
Determining the amount of rainfall over an area is like solving a big jigsaw puzzle, without knowing what the picture is supposed to look like when you're done. Hydrologists use tools like rain gauges, weather radar, and satellites to figure out which pieces of the puzzle go where.
In order to measure how much rain has fallen, the National Weather Service uses over 10,000 rain gauges. This one has a scale which is used to determine the amount of rain fallen over a given period of time. Another type of rain gauge, the tipping bucket, sends out electronic signals as rain falls into the collector that tips when a fixed amount of water has been collected. To ensure timely forecasts, most rain gauges are equipped with radio transmitters, which immediately send measurements to forecast offices.
Because rainfall can vary widely from place to place, knowing how much it is raining at just the gauge locations does not necessarily tell us how much it may be raining somewhere else. Because of this large variability, hydrologists use other tools to fill in the blanks. This is where weather radar comes in.
Using weather radar can be compared to using a flashlight to find something in the dark. When the beam of light from a flashlight illuminates an object, some of the light is reflected back and you can see the object. Instead of light, radar sends out a radio signal. Water, in the form of raindrops, snowflakes, also referred to as precipitation, reflects the energy transmitted by radar. The longer it takes to receive the return signal, the farther the precipitation is from the radar. The stronger the return signal, usually the more precipitation.
Satellites may also be used to help estimate rainfall amounts, particularly in areas where radar beams can be blocked by mountains. Hey, I'm done!
More than half of North America experiences snowfall at some time during the year, and in many northern areas, snowfall is most of the yearly precipitation. Snow is crystallized frozen water. When snow accumulates, there is a large supply of frozen water just waiting to melt and run into rivers. Most people think of snowfall in terms of the depth of snow. For example, weather announcers on TV report inches of snowfall. Hydrologists think about snowfall in terms of how much water it contains. Snow can be very dry and powdery, with only about an inch of water for every 10 to 20 inches of snow. It can also be very wet and slushy, with about an inch of water for every 2 inches of snow.
We're interested in snow water equivalent, which is how much water you would have in the snow if you were to melt it. We need this information in order to predict how much water will run off into rivers and streams when the snow melts, and also whether or not that snow melt will lead to flooding. We also need to know the snow water equivalent in order to determine how much water to retain in reservoirs during the winter and spring, and in order to make that water last through the summer and fall.
The snow hydrologists who gather this information use many kinds of equipment to make measurements of snow water equivalent.
Rain gauges, anemometer,
telemetry installation right here,
gamma detector,
solar panel,
precipitation collector,
pressure transducers, the temperature detector, temperature probe box,
air temperature sensor.
We've got 52 inches plus of water content stored out in the snowpack.
By inserting the tube into the snowpack, hydrologists obtain a sample of the entire depth of the snow cover, which they weigh to determine how much water is in it. This method only tells the snow water equivalent for a tiny area. To measure a large area, hydrologists sometimes use a low-flying aircraft. A special sensor on the aircraft measures natural radiation emitted from soils. This harmless radiation is blocked by water in the snow. The more water contained in a snowpack, the less radiation gets through the snow. So by measuring how much radiation is blocked, hydrologists can determine the amount of water in the snow below the aircraft flight line. Once hydrologists know how much water is contained in the snow, they can more accurately predict how much water or runoff to expect when the snow melts. Hydrologists usually think of runoff as the rainwater or snowmelt that doesn't soak into the ground or return to the air through the process of evaporation. It's just waiting for a place to go. Runoff can occur on all types of surfaces: roads, roofs of houses and buildings, sidewalks, and on surfaces that are covered with vegetation. Runoff can travel along the surface of the ground, eventually finding its way into street gutters, small streams, creeks, and finally into rivers, which make their way to the oceans. Because runoff collects water from widespread areas, small amounts of rainfall, say 1 inch, can cause a river to rise many feet and sometimes flood. It is therefore important for hydrologists to study runoff and be able to forecast the types of situations where it would be a problem.
Flood prediction depends critically on our ability to estimate runoff. The amount of runoff that can occur depends on many factors. If there's a big rain, the soil will soak up as much water as it can. Any more rain falling onto this wet soil becomes runoff. Some kinds of soil can soak up more water than others.
The speed at which water moves also determines the amount of runoff. Water moves faster over surfaces such as paved streets and gutters, and slower over rough, porous areas such as lawns and other areas covered by vegetation. Also, runoff travels faster over steep slopes than over flatter areas. Rivers convey runoff to the ocean. When the volume of water exceeds the river channel's capacity to contain it, flooding occurs. The role of the hydrologist goes beyond scientific measurements, data gathering, and predicting river floods. Since hydrologic forecasts are vital to those at risk, they must be communicated.
Hydrologists work with TV and radio stations, emergency managers, and city officials to determine how to better understand and utilize hydrologic information and then communicate it to the public.
The National Weather Service communicates forecasted river levels nationwide, 24 hours a day.
National Weather Service
Timely warnings inform the public when and in what areas rivers will flood and how to avoid being caught in one. These advance warnings have saved lives and property time and time again.
Very often, what we'll do is contact a severe weather forecaster actually at the National Weather Service office and say, what's happening? A good many of the decisions that we in emergency management make are going to be based on what we hear from the weather forecaster.
Whatever part of the county the Weather Service tells us that the problem's going to be at with the flooding on there, or a lot of rain, or the hailstorms, that's the part of the county we're going to put our deputies at to be able to help out the citizens.
We're not just in front of a computer anymore. We become communicators. We work with the police departments, the sheriff's departments, fire departments, and emergency managers. We become their technical resource through interactions with the National Weather Service on what they can anticipate, where they can expect the worst problems to be.
So that they can have one step up on the weather that's coming in that day.
So the hydrologist's role is crucial in letting me make the decisions to know how far we're going to have to evacuate, how much do we notify people. And the really interesting thing about the hydrologist is they give us accurate information. People don't want to get a warning that's inaccurate, because pretty soon you're crying wolf. So the hydrologist in emergency management is crucial.
Hydrologists are scientific specialists. Their forecasts are glimpses into the future, granting us precious time to prepare for emergencies, saving lives and property. Hydrologists prepare us for the effects of floods. Their forecasts are also relied upon to meet the needs of cities, small towns, industries, and others that depend on adequate supplies of water. Dynamic and evolving, the science of hydrology moves forward. Ongoing discoveries and technological breakthroughs raise new challenges, opportunities for the hydrologists of tomorrow. If you're interested in a career that saves lives, solves serious problems, and advances the frontiers of science, pursue the study of hydrology. What can you do now to become a hydrologist? If you're studying science, mathematics, and computers, you're already on your way. Go to college and take advanced studies in these subjects, as well as hydrological science. Read more about hydrology. You can start by visiting this website,